Hello everyone, this is the lecture 2 of metric space unit 3. In the unit 1 we have seen what is the definition of continuous function on a metric space, and we have seen what is the sequential criterion for continuity. Okay, in this lecture we will see some theorem for for checking that function is continuous or not. The first one is that let x comma d and y comma d star be two metric space. Let f from x to y be a function. F is continuous if and only if f inverse g is open in x whenever g is open in y. That meaning simple hoche. So if we have a metric space x comma d here, and we have another metric space y comma d star, and f is a function from x to d. Now this function is continuous if and only if jodi mor pake gote g open set thiba y re, then the inverse collection f inverse g is also open in x habar kotha, and the reverse also true. Whenever g is open in y, f inverse g jodi open in x haba, then f is continuous. So we will first prove what's the necessary part, and then we'll prove the sufficient part. The necessary part, actually exam re emti pochir pare, f is continuous if and only if it pulls back open set to open set. F is continuous if and only if f inverse pulls back, f pulls back open set to open set, open set to open set. So the pulls back open set to open set hala, and I can say that f is continuous. Okay, the proof the necessary part. What is the necessary part? Let f is continuous and g is open in y. F is continuous and g is open in y. What's my claim? My claim will be f inverse g is open in x. गोटे जिनिस मने पकामा में कि किसी जिनिसटा किसी सेटटा x, suppose we have a metric space x and s is a subset of x. Okay, so s is open in x के बेवा जदि ता प्रत्येक point is an interior point, every point is an interior point. To show s is an open set in x, we take an arbitrary point and we find a neighborhood of that point such that that neighborhood lies in x, in s. So mote dekhaba che ki we take an arbitrary point x belongs to s, we find a neighborhood of x such that that neighborhood contain in s. Okay, so mote prove kora che f inverse g is open. So I will take any point from f inverse g and I find a neighborhood of that point such that that neighborhood lies in f inverse g. Acha case 1 gote jinis korma, if f inverse g is empty, f inverse g ta jodi empty haba, then we know that empty set is open in x, and we know phi is open in x. So f inverse g is open in x is jiva. Case 2, if f inverse g is not equal to phi, so let a belongs to f inverse g negally. Suppose this is my x comma t and f inverse g is here, and I have taken a point a belongs to f inverse g. Now eta f inverse g re oche, tar meaning kan haba f of eta pakka keno thiba g re thiba kene, because this is a inverse image. Jodi gote element ta a inverse re oche, tar mapping ta pakka keno podba ga g re, f of eta pakka keno podba g re podba. So fa belongs to g oche. Given the given g is open in y, given G is open in Y. That means what? There exists a neighborhood epsilon greater than 0 such that S of open ball center at FA of radius epsilon is contained in where? G. Now बहुत के डायग्राम टिके देखामा तो FA टा केन अच्छे G रे तार गुटे neighborhood टे भारवा. What is that neighborhood? S of FA epsilon that is contained in G. That is contained in G. Now again गुटे जिनिस संगे आमे यूज ना करवा तेल continuity. Now since F is continuous on X, that implies what? F is continuous at X equal to A. तार मीनिंग क्या है? F is continuous at X equal to A. तो ई पॉइंट फंक्शन कंटिन्यूअस अच्छे तो by using the definition of the continuity for epsilon greater than 0 there existed delta positive such that fx टा केनो बिलोंग करवा S of FA epsilon whenever x belongs to केनो S of A delta. तो जदि फंक्शन टा कंटिन्यूअस है for a given epsilon तो there exists a neighborhood of A such that जेबे जेबे x टा ई भितरे थिबा तार इमेज टा ई भितरे पड़वा. This is nothing but what? This ball is nothing but S of FA epsilon. Okay, so fx belongs to this ball whenever x belongs to this. Take implies I can say that for all x belongs to this, the fx belongs to where? This one. So the f image of S of A delta is contained in S of f of A epsilon. कोई परमा की नहीं. तो because every point जेबे जेबे एक्स्ट्रा इने पड़वा तार इमेज टे इने पड़ू छे तो मीन्स सेट ऑफ ऑल इमेज पॉइंट f of S of A delta कहार भीतर रहबा भीतर रहबा एंड ई जिनिसटा कहार भीतर अछि भल के देखो ई जिनिसटा कहार भीतर अछि G भीतर अछि. सो हेंस आई कैन से दैट कान हला f of S of A delta is contained in G means इतार इमेज ता G भीतर अछि. तो implies I can say that S of A delta is contained in F inverse G. कोई परमा की नहीं. तो मीन्स ए रो गुटे neighborhood भालला नो S of A delta कहार भीतर अच्छे F inverse G भीतर अच्छे. implies देखो हमको ओपन सेट देखा हुआ था. I have taken a point A belongs to F inverse G तार neighborhood टे खुजली जे कहार भीतर अच्छे F inverse G भीतर अच्छे. implies I am डायरेक्ट हमें कोई परमा F inverse G is open in X or A is an interior point of F inverse G implies F inverse G is open in X. So this is the necessary part where we have taken F is continuous and G is open in Y. मोते claim करवा था F inverse G is open in X. If F inverse G is phi then obviously phi is empty set is open set in X. Claim 2 or case 2 if F inverse G is non-empty I have taken a point A belongs to F inverse G. Since A is in F inverse G तो F A रो image टा G रे पड़वा F A belongs to G but G is open in Y so there exists a neighborhood or open ball centered at F A of epsilon radius is contained in G. Now since function is continuous on X so F is continuous at the point X equal to A. For a given epsilon greater than 0 that exists a delta positive such that fx टा केबे केनो बिलोंग करवा दिस बॉल रे केबे बिलोंग करवा जदि x टा ई बॉल रे थिबा बेले. तो implies जदि समस्त सब पॉइंट रो इमेज टा इने पडुछे तो so f of the set of image point is contained in this ball and which is contained in G. implies f ई बॉल रो इमेज टा G भीतर अछि तो ई बॉल टा पक्का f inverse G रे थिबा मींस प्रत्येक पॉइंट रो इमेज टा G है. what is f inverse G is collection of pre image so S of this A delta must be in F inverse G. So we have a neighborhood of A which contain in F inverse G. So F inverse G is open in X. Now we'll go for the sufficient part. What's the sufficient part? Given us whenever G is open in Y, F inverse G is open in X. my claim is that f is continuous on x. So continuous on x means I will take an arbitrary point on x and I will show that the function is continuous at that point. Let a belongs to x. My claim is to show that f is continuous at a. Now again, a belongs to x implies f of a pakka ke no thiba. Why the image ache a cannot porba? Why the for all epsilon greater than 0, s of f of a epsilon is an open ball or open set in y. By given condition, f inverse of this ball or this open set is also open in x. Okay, that implies a belongs to f inverse of s of fa epsilon. A keno thila fa re fa this center ball, we have a center f of a epsilon radius ball ta eta keno open ache y re. तो ता प्री इमेज ता केनो पढ़ू छे तार ना देया लखना s इनवर्स ऑफ fa एप्सिलॉन और इथि a पक्का बिलोंग करबा जदि a बिलोंग नै करथिता तो f of a ता इने ना पड़े जदि a ता बाहर के रहबा जदि a ता बाहरे रहला मींस तार इमेज ता केनो पड़बा का ई बॉल रे ना पड़े बिकॉज़ व्हाट इज दिस बॉल f of a एप्सिलॉन सेंटर एट a of the image एप्सिलॉन रेडियस एप्सिलॉन बहुत बुझवा लगे चेष्टा करो हमें जगह रे तो वी हैव ए बॉल open set in y. According to condition, this inverse is an also open in x. This is number as inverse of f of a epsilon. This is open in what? X. Okay. तो एटा मोर क्लेम अच्छे कि एटा इ बॉल रे थिबा जदि एटा बाहरे रहला तो एफ एटा किनो पड़बा इ भीतर ना पड़ी पारे बिकॉज एफ एटा काना इ सेंटर बॉल वाला है तो एफ एटा बाहर के पड़बा सो पक्का एटा किनो अच्छे इनवर्स इमेज रे अच्छे ठीक अच्छे that existed delta because this also an open ball, this is an open set and eta ine अच्छे that existed delta such that s of a delta is contained in because open set है तो neighborhood बाहर वासे कार भीतर रहबा f inverse of s of a epsilon implies f of s of a delta is containing s of a epsilon. So means image of this ball is containing this ball. ठीक implies this is the definition of continuity. F is continuous at x equal to a implies f is continuous on x. So this is the sufficient part. Thank you.